Okay, so in this video, I wanted to talk about another data structure called a stack. A stack pretty much it's a data structure that can store and retrieve data in last in, first out order. So what do I mean by that? The best way to think about it would be maybe a stack of plates. Okay, so for a stack of plates, usually the plates are last in, first out, right? So we have a plate, and then as we start collecting the plates, we start putting them on top. This, right? This is the top here. And then when you want a plate, then you retrieve the last one that was put on top, right? So then you pop this plate off here, and then you get your plate, you put your food on it, or whatever it is you're going to do with it, right? So you take this one off, then this one is gone. If you want another plate, then you pop this one off, then you have that plate. Eventually you pop them all off until there's no more plates. So that's the idea of last in, first out. Okay, so there's two types of stacks. There's a stack that's called static. It uses an array because we have to have a fixed size. And we have a dynamic stack that uses a linked list. And if you remember from the last section, linked lists are dynamic data structures, so we can add and remove however many nodes we need. Right? So for my example here, I wanted to go over the dynamic stack that uses a linked list to implement it. Right? And usually a stack has these three operations. Right? It has the push, that's putting the plates on the stack. It has pop, that pops the stack off. And we also need a function or an operation to check and see if the stack is empty, if there's no more plates left. Right? So we'll go ahead and set this up, and then we'll use it and see how it works. Okay, so since the stack uses a linked list, we need to define a struct. We can take my cap block off. We need to define the struct first for the node. Right, so we can do struct so that's for the node. Then public will have our operations that we can use on the stack. So the first one is going to be the push. So that one is a void function. We can call it push. And we need to know what we're going to push on to the stack. Right, for my example, I'm going to keep it simple. I'm just going to use numbers. So I'm going to do int number. So that's our push operations. Then we're going to do the pop operation. So pop is going to pop a number or a plate off the stack. You can do this two different ways. I'm gonna do a return for an int, right? Because we're gonna work with integers. So we're gonna pop, right? And there's no argument here because we're just gonna pop whatever's on top. And then the last operation is going to be is empty. Usually when you see a function with the word is empty, is full, is balanced, is anything else, that usually means that it's going to return a Boolean value, right? It's going to return either true or false. It's some sort of logical test, right? So that's what this, when it says is this that. So it's going to return a bool, is empty, and then we'll do the code for that. So those are the three basic operations for a stack. Okay, so the other thing we need is we need to keep track of the top of the stack, right? As we start putting items in the stack, the top is going to change. And as we start removing them, then we need to also adjust the top, right? So we can keep track of that here in the private section of the class. We'll use a pointer, a node pointer, right? And we'll call it top. And then the other thing we need, I forgot, is we have our three operations for the stack, but we also need a constructor to initialize our object, right? So when we create a data stack, we need the constructor for that, right? So the constructor has to have the same name as the class itself. So dynamic stack. And then here we will initialize the top. And since we haven't created our stack yet, we're just initializing the object. We'll set it to null. So this is the constructor. Okay, and then since we're using a linked list, we need to, in our struct, we need the value, and we need the pointer to next. And then we need the constructor for the node itself. Node. And we can set this to null as the default parameter. And then here, because I'm using the same names for the parameters as the instance variables, because of ambiguity, I'm going to have to use the this pointer. So this value, this meaning whatever whatever class or struct I'm in. So this value, this one here, equals this value. Right? So whatever's passed to this constructor, the parameter is going to be assigned to the instance variable here. And I'm going to do the same thing for next. Okay, so for our stack, so far all we have is our pointer. I'm going to draw it here. We have our pointer called top. And top points to null, right? But rather than drawing it like this and then null, what I'm going to do instead is I'm going to draw a slash through it. Right, that means it's null at this point. Okay, so let's say I want to create, or I want to add something to my stack, right? So I'm going to push, let's say I want to push the value 5. Okay. So then what happens with this operation is it's going to create a new node. Create a new node. The value is 5. And it's going to point to whatever top is pointing to. Alright, so at this point top is pointing to null. So then this will point to null as well. But we need to reassign the top now to keep track of, because now we have a node. So then top needs to point to this new node here. So then this top is no longer null. Okay. So then we're gonna my eraser for some reason. Okay. So then now I'm gonna push another value. Let's say I push 7. Alright, so then this operation here is going to create a new node. We're going to put the data in at 7. Then for the next here, it's going to point to whatever top is pointing to. So top is pointing to 5. So then this node is going to point also to 5. And then we need to update top. So then top is no longer pointing to 5. Now it's pointing to 7. Okay, so then we'll push one more value. I'll write it here. We'll push 8. Right, so then this operation will create a new node. Put the 8 in there. 8 is going to point to the next here, is going to point to whatever top is pointing to. And that's pointing there. And then we need to update top. So now top points to 8. Okay, so now how do we write top in code? I'm sorry, how do we write push in code? Right, so it's only one line. It's very simple. So we create the new node. We get the value from the parameter, so number, and then we assign to the next, right, the next here, the pointer, whatever top is pointing to, so top, right, and then we reassign the top to the address of the new node. So it's just one line. Okay, so now let's work on the pop operation. All right, so let's say I want to pop the last value that was put into the stack, right? So I'm just going to do pop, right? There's no parameter. It's just going to pop whatever's on top. So what we're going to do here is we're going to get the value from whatever top is pointing to. So we can declare some sort of variable like num, and we're going to set it equal to top value. Right, so top value is going to be 8. Right? Then from here, we need to, well, I guess we could do this way. We can create a node, a temporary node, and we'll assign it with the address of top. Right, this is a temporary node pointer. Then what we need to do is we need to reassign top. Top is now going to be top next, which is here. So this node, whatever it's pointing to, is going to be the new top, right? So top equals top next. Right, so this line here essentially does this. Right? It just gets the top and reassigns it here. Then the last thing is, because we stored our node, or the address of the node, we stored it in a temp variable. Then what we can do now is delete temp. Yeah, so then this is just going to cross that out. And now we only have 7 and 5. Okay, so let's try another one. Let's execute pop again. So then we're going to retrieve the value before we delete it, right? So this operation will do that. So that'll get the 7. Then we'll set it. We'll set this node address to a temporary variable. Then we'll do top equals top next. So top next is right here. So it's doing this kind of deal. So then this goes away. And then the last thing is to delete the temp address. Okay, so we can pop the last value. Alright, so we're going to retrieve the 5. So this will be 5, because top value is 5. Then we'll assign the address to a temp variable. Then top is now going to be top next. So the next here is null. So then now top will become null as well. And then we'll delete the temp. Alright, so that we don't have it pointing to anything anymore. Now our list is empty. Okay, so let's go ahead and code this out. Okay, so let's declare a variable called number, and number is going to equal to the value of top. Then we're going to create a temporary node. Temp, and we're going to set it equal to top. Then we're going to reassign top to top next. And then the last thing is to delete temp. Right, so here we retrieve the value, get value, create a temp node or temp node pointer, sorry, so we can delete the address, right, because we're not going to need this memory location anymore, so we need to get rid of it. Then we're going to reassign top, and then delete the old address. Okay, so isEmpty is pretty simple to code. So let's look at our example real quick. Right, our list is empty. So the only thing that indicates that is that top is null. Right, when top is null, it's not pointing to anything, then we know there's nothing in the list. So if top is null, then we return true, right? Because if there's nothing for top, then we have nothing in the list. Else, if it's not null, then return false. Right, so if there's something in top, then we know it's not empty, so then this returns back a false value. Okay, so let's try out our stack, see if it works. So let's create a stack object. What did I call it? I called it dynamic stack. I can just call it S. And if I write it like this, this will automatically call the default constructor here. Okay, so then I'm going to push, just like our example, I'm going to push 5. Oh, since I have an object, make sure you use it. So S push 5, S push, I think I did 7, and then let's push 8. Okay, and let's pop them all out. Okay, so now that we've pushed a few values, let's go ahead and use the pop operation so we can actually check and see if our stack was implemented correctly. So I'm going to cout s dot pop, maybe a new line. Right, so what are we going to pop? Right, so first we push 5, then 7, then 8. So if this is working correctly, then we should get back an 8. So let's try it out. Oh, I have an error. Oh. Here. Right, we need to return, this is an int function, so we need to return the number. Sorry about that. Okay. Okay, now let's try it. There you go, we get an 8. Let's say I pop again. 5. Now we should get back 8 and 7. 8 and 7. Took a bit. And then finally we'll pop the last value. Eight, 7, 5. Right, but let's say we don't really know how many values were pushed into the stack, or we don't want to be typing this 3, 4, 10 times. You can do instead, I'm going to cut this. We can use our function if s is empty. Actually, while it's not empty, right? If this is empty, we don't want to pop anymore. All right, so while it's not empty, oh, and this is supposed to be while. Sorry, I got too excited. Control F5, and that does the same thing. All right, as soon as it became empty, then the loop broke. Okay, so at this point you're probably wondering, what is the point of using a stack, right? When is this used? Well, the most common use of it is when you do, or when you undo operations. Those are implemented using a stack. So I'll show you an example. Okay, so for an undo operation, here's Microsoft Word, and here I have Excel. I'm going to use this to implement my stack. Okay, so let's say I type some text, right? That's example. So then here I have I typed example. Then I'm gonna use the bold operation. So then I used bold, and then I'm gonna italicize. I used italics, and then what I want to do is maybe change the font color to red. Okay, change to red. Okay, so then now what I'm going to do is I'm going to use the stack I created, or the stack that's in Word, and I'm going to use the pop function that's in Word. It's called undo. So I'm going to undo. So then that popped this off the stack. Now this is the new top here. I'm going to pop that also. So then now my text changed back to bold. Get rid of that. And then maybe I can do something else here. I can change the font to 48. Change font to 48. And then maybe now I can change the font to green. So, green font color. Right? And then it's like, you know what, I don't want to do green anymore. I'm going to undo. So then I get rid of this. I'm going to undo. I'm going to pop again the 48. So that gets rid of that. And then I'm going to pop again, get rid of bold. And then I'm going to pop one more time. I guess I had bold before. One more time, and then that gets rid of the example text. And then I can't. Oh, I had typed that earlier, so I can't pop anymore, right? And that gets rid of everything in the stack. So that's how undo is implemented. I just thought I'd show you a more practical example. Well, I hope this example and everything we went over has been informative. If you have any questions, you feel free to email me anytime. And I just wanted to thank you for watching the video.